see this. Great. Okay.
I'm gonna refresh over here.
No, you should click videos
Yeah, click videos.
and refresh again. Go to Chrome. Okay, refresh.
Okay, it's live.
This one.
There we go.
Woo, we got
it.
Refresh. Yeah, now you
Okay,
see
it's
it.
live.
And then we here. Yeah, so you're set up. Good luck.
All right. Wish me the best of luck.
You got this, man.
Make sure to say it on the Discord as well.
Oh yeah, that's also a pretty good point.
Yeah.
Like send
let's
another
make
quick
one
announcement.
more.
Go to Chrome, get the live stream link, and then that announcement that you make on Discord, paste the link as well.
Where's the live stream link?
Just search up DSC FIU, and then it should be there. It should come up.
All right. Let me just stop the live stream so I can.
Oh wait, don't stop it, because then it's going to.
Close it over there.
Yeah, then it's going to restart it, and then we have 2 videos.
All right. Let me just DSC FIU.
This is we're fine.
Mm-hmm. I can book it. It's fine.
Yeah, and then click it. And then, yeah, cool. And then you share that link with them.
Yo, FIU don't kick me out for what's showing on the YouTube thumbnails. All right. Let me just. All right, now let me go back to Discord.
Yeah.
Just ping Game Dev and be like, hello friends. We're continuing to build our Flappy Bird. Oh, thank you for updating the slides.
Yeah, perfect. Good luck, bro. You got this.
You got this. Another one.
Right, take care, man.
Thanks for setting it up.
Yeah, of course, of course.
Let me just get charger ready.
Bye.
Alright, 3, 2, 1. Alright, so hello everybody. Welcome to the stream. Took a little while to set up, getting used to being back on campus once again. So for today's workshop, we're going to be continuing off of what we last did on Zoom with the Flappy Birds project. So essentially where we last left off was getting the bare essentials as far as our ground movement and Flappy being able to be animated along with Flappy's jump mechanics. So if I'm to press play right now, we see that we got Flappy jumping in, and we have the ground coming in, working just as fine. So for today's workshop, we're going to be focusing on getting the remaining things done as far as adding the pipes, generating the random pipes, along with adding a score counter. Well, let's see what we can get done as far as today's workshop. So the first thing that we're going to focus on is adding the pipes themselves. So the first thing that we're going to do is, for those that are watching, make sure that you have your GitHub repo for the first part. I linked it in the game dev channel for the GDSC Discord. So when it comes to our pipes, the first thing that we're going to do is we're simply going to drag the two pipes that we have currently within our timeline right here. I'm going to drag pipe 1. I'm going to drag pipe 2. And we are going to rename them so it's easier for us to recognize. Alright, so now that we have our pipes, let's see if we can mess around with them a bit to make them look like how they usually do in the games. So just as a quick recap for those that are attending, to move any game objects in Unity, just press W and you'll be brought to this green and red arrow that shows up here, and you can simply drag it up and down. So let's go click pipe 2 and drag it up. And just as a recap, if you ever want to move within a scene in Unity, right click on the scene and you'll be able to drag the scene to wherever you want. Let's see, let's move it just a little bit up and a little bit down. I'd say that's a good enough start. So now here comes one of the important beginner concepts when it comes to using Unity is learning how to make a parent object. So essentially what a parent object is an object that houses that is the main object that hosts all the details of your code. Not code, your game object. So what we're going to do is that we're going to combine both pipe 1 and pipe 2 using a parent object, so that way we don't have to mess with them individually. So the first thing that we're going to do is we're going to right click on the hierarchy, and you're going to click create empty project. And what you have right now is just the game object itself. Very important thing that you want when it comes to creating an empty game object is to be able to reset the position. So easy way to do that is if you go to your inspector tab, right click on this button right here, and you'll be brought to options. You're going to do click reset, and you will have your empty game object reset to 0, 0 on both the X and Y coordinates. Now what we're going to do is you're going to hold control, click no, not like that. Click pipe 1 and then control, click pipe 2. And then what you're going to do is you're going to drag it on top of game object. And now when you move this game object, you're able to have both the pipes moving wherever you want just fine. Now, I guess since you're in the audience, could you tell me what happens if I were to press play right now with the pipes?
I mean, I guess like if they're already like moving to the side. I mean, I guess like they would be moving like both to the side at the same time.
Let's see. Let's see.
See? I mean, I just thought here, and my computer has something that's like started.
That's not good. I just want to get you curious. So here's what's happening right now. Two things. One, we don't have any code attached to our pipes, so they do not move to the left like the ground does. And the second thing is that if I were to press play again and just notice how the pipes are in the background in the scene. And if I were to press play, they would still not show.
You need to put them like in the layout to the front, right?
Yes, exactly. So this is touching up on what we discussed back in part 1. So very important is ordering of layers. Are you familiar with Photoshop?
Photoshop, I've used it.
Yeah, so basically in Photoshop there's orders to layers for a picture that you want to create. So if you want a certain picture to be in the forefront, that comes first. Same idea with your hierarchy in terms of your game objects. So in this case, we need to edit our individual child objects, so pipe 1 and pipe 2. So if you go into the inspector tab, you will see there's an option, the last option that says order in layer. And what we do is we probably set it to a high number like 10. Because really that's going to be at the very forefront.
And you can't do that, you know, like in the game object itself, like in the parent node, not in the parent object, not like on each of them individually.
Yeah, the reason for that is because the parent object does not have the sprite rendering component, so we can't adjust the order in layer. We have to do that individually through the pipe layer. But the good thing is that once you change that individually, it transfers to the parent object. So you don't have to make too much adjustments after that. Now, the other issue that we need to tackle is the movement. So last time on the first workshop, we focused on creating a move left script that allowed us to move the ground indefinitely. And I guess just to go into more detail about that ground script is essentially how we rearrange that ground script is that once the ground reaches a certain coordinate on our scene, our code will let us know, hey, that's the end. Let's return back to the very beginning. So that way it loops endlessly. And we have that code available to us. It shouldn't be any different if we attach the pipe, right? So let's go to add component. Move left. And let's adjust it to a speed of 2 and see what happens. Yeah, so we have something wrong right there. So I can let me just explain that in more detail. So I'm not sure if can you see the red error on the bottom?
Yeah, I can see it over there.
Yeah, so essentially, just to translate that error, missing component exception. There's no box collider attached to our game object, but the script is trying to access it. So the way that we wrote our script in the first workshop was we wanted it to access a certain component within our game object. So just to give an example, for the ground a game object, we wanted to access its box collider so we can get all the information from that box collider so we can get the coordinates and know where exactly it goes out of frame so we can repeat the ground layer going to the left all over again. But the reason why it's not working with the pipe in particular is because the pipe has no box collider to call upon. Right now it's just following the script of just going left, and it can't go any further than that. So this is where something important comes in terms of Unity. It makes your life so much more easier. So what we're gonna do is we're gonna discuss the importance of tags. So let me see if I can. If you go into your inspector tab, you should see a tab that says tag, and it says untagged at the moment. You will see a bunch of different labels for a bunch of different labels that you can use for your game objects. So I'm going to show you how you can create like some of the tags that we're going to use for this workshop. So we have ground, we have pipe, and we have column. So very important that you remember the names of your tags, because when we start to input them in the code, Visual Studio is very picky with how you spell your tags. If you don't spell them exactly how you wrote them in the inspector panel, you will have compilation errors when you try to run your code. So let's demonstrate that further by actually diving into the code right away. So we're going to go into assets, we're going to go into the script folder, and we are going to go to movement left. So right where we left off, we have our functions in terms of how our ground movement will move along the x-axis and how it checks when the ground reaches the target length to repeat all over again. So one of the things that we have to contend with is the fact that we cannot use Box Collider 2D for all cases, because we really only have that set to one object, which is the ground. But we don't want to do that. We want to write our code in a way that it's all-purpose using the tags. And this is where the tags come in. You can simply mention the tag that you want to check, and then the code will compile just as normal. So what we're going to do first is we're going to encase this code right here. We don't have to change anything with this code in particular. We just need to encase it in an if statement that checks for the tag. So let's start with an if statement. If game object dot compare tag and then this is where it's really important that you name your tags correctly. Ground. And just for this sake, let me just make sure I copy this so there's no errors. So let's walk through this script right here. So at the start of our game, if game object compare tag ground, so if we detect that one of the game objects has the tag ground, it will execute this code right here, where we get our Box Collider 2D, and we set our value for ground length equal to the size of our floor collider, which its value is given based on what we extracted from setting up the Box Collider in the first place. So now we're not done just yet. Now we're gonna superimpose this onto the other end, the other part of our code, which is to check if the ground reaches the target length. So yeah, be very careful with this one. So that'll be if game object dot compare tag ground all right, then what I'm gonna do is I'm gonna paste the code again. I'm gonna try my best to line it up as best as I can. I may have to go back and fix it if there's any indentation errors. But let's save and see if there's any indentation errors. So same logic applies here. We have an if statement that checks if the game object that we're checking every frame is the ground tag, and if it is the ground tag, it executes the code that we have here, which if our transform position x coordinate is less than or equal to negative ground length, which is where our stopping point ends before we repeat the ground, then it executes that code to repeat the ground again. So let's save and see what happens. Oh, Unity, please. Yo, I swear, man, like, no matter how many times you rehearse for presentations like this, Unity always finds a way to, crop up doing stuff like this. It's just the name of the game. All right, let's just give it. Oh, you watch. 50 seconds to compile this. Just throw in an error.
I mean, it's not even like long code. Why does it take so long to compile? I mean, I guess it also like applies to me because like it's still loading over here in the Unity. It definitely like open up.
All right, so what we're gonna do right now is that this error is still gonna pop up. So here's what we're gonna do. We're gonna go to ground. We're gonna go to the tag that we have for ground. Let's also check that for this ground as well. And there we go. That removes our issue with the missing exception. So now we reformatted our code to check for any tags and still run the same code that we had back from the first workshop. So with that being said, let us begin with actually working on the column spawner. So the first thing we want to do before we start on the column spawner is to make a prefab. So essentially what a prefab is, a prefabricated object. So in other words, if you like the way that you set up a particular object, so let's say we like the way that we set up our pipes, right? What we can do is you can go to your project, go to your assets, click your parent object, and drag it all the way into your prefabs folder. And there you go. What Unity did for you was made a template of your game object. So all the settings that you made for your pipe remain the same when you access the prefab. So that's a load off your shoulders, so you don't have to keep making two individual like pipes and lining them up to like where you want them again. And just to showcase it, um, if we open the prefab folder, I mean the prefab for our pipe object, you can make small adjustments, like of whatever coordinates you want, and then that'll be saved individually into your prefab. So if you need to make any quick adjustments, you can do so. You can do so there. So let's go back to, now that we have our prefab, let's take a moment to remove it for for a second, because we already have it saved and we can just return back to it at any point. Let's see. So one of the things that we need to focus on is solving an issue. So already we have one issue. We could just keep duplicating the same pipe and just switch it around in different coordinates, but that's not efficient. Imagine how many pipes you have to keep doing that to make it endless. There's an easier way to handle that, and essentially what we're going to be creating is a spawner object. So essentially what that is that a spawner object allows us to grab any prefabs that we have and just pop them into the scene. And that saves us a lot of time because we can direct where our objects spawn, and we can just set the amount of details as far as like how much things we want to spawn in terms of our prefab. So first thing that we're going to do is we're going to create an empty game object. Same idea as before. We're going to reset, and we're going to zoom in a little bit. Let's have it at least close to right here. Now, very important thing that helps out when it comes to making empty game object is that if you were to, at times if you were to click out, this arrow will disappear and it'll make it harder for you to see where your game object is if you don't have like any sprites or art assets attached to it, like say Flappy, for example. So one of the neat features that you have at your disposal in the inspector tab is a color tag button. So you see this cube right here? You're gonna left click that, and you have different ways of differentiating your game objects in terms of either a shape or a shape like this, for example. So let's keep it red so we know exactly where our pipes are going to spawn as we start building up our code. So let's rename it column spawner. And then what we're going to do right now is we're going to create the script for the column spawner. So we're going to go to scripts, and we are going to right click on scripts. You're going to have this window that says create and then C# script, and we're going to name it column spawner. All right. Any questions so far? None? All right, so let's dive into the actual code for the spawner. So, all right, so there's several things that we need to consider when it comes to our column spawner. We need to consider the following things. We need to construct a way of when the game starts, we can call upon a method that spawns in our prefab object. And we need to find a way to populate the screen with more pipes as we continue through the game in respect to time. So first thing that we're going to do is we're going to create a public game object. column prefab. So essentially what this is that we're going to be grabbing the prefab that we made from earlier, so that way our script has access to the information from our prefab. So that way this script can mess with the details, so that way we can get it to spawn on our screen. So first thing we need to do also is we need to create a new spawn a new pipe layout. Spawn continuous amounts of pipes. Just to save that for later when we get to filling up those bits with the code. So first, before we dive into that, we need to make a new method for spawning the actual pipes themselves. So we're gonna do void spawn column. And what we're gonna do is we're gonna initialize a variable for a game object. So game object new column equals, and we're gonna write instantiate. So essentially what instantiate is, it's just to put it in simple terms, instantiate means create. So on create, for example. So when we run this code or run this method in particular, we create a new game object at the start. And instantiate is going to ask for a parameter. We're going to use column prefab. So we're going to create our pipe layout so that way it spawns. So column prefab. Now we're not done just yet. So like with the previous code before, we're going to need to be making a new vector2 for our column spawn, since it's going to be also moving to the left. So what we're going to do is we're going to reference our game object as new column dot transform dot position equals new vector 2. It's very important, just as a recap, it's very important that you start your new column transform position with a new vector 2, because essentially what a vector 2 is that it handles the coordinates of your game object in terms of x and y. So if you want to move to the left or right, that handles the x coordinate. You want to move up or down, that handles the y coordinate. So let's think about what we want to do for our pipe. We don't want it moving up and down, correct?
No. Well, I guess it depends. Like, if you want to make it harder, like you could actually make it move up and down, but that would be later in any case.
Actually, the funny thing is that we're gonna get to that real soon. So, as of right now, we don't want to go too crazy with the y coordinates just yet, but we definitely want to move the x coordinates to the left, like we move the ground. So with vector 2, it asks for 2 parameters, which is for x and y. So what you're going to do is, in this case, you're going to write transform dot position dot x. Well, let me correct myself in saying this. The x is going to roughly stay the same. What we need to change is the y column, the y-axis, because we're going to go into exactly what you were talking about like just a few seconds ago, where we're going to randomize our column prefab so it's not in the same place every time a new one spawns in. So what we're going to do is we're going to create a variable called rand y position. Now we don't have that rand y position initialized as a variable just yet. So let's do that within spawn column. So that's going to be That's going to be float rand y equals, it's going to be, wait, let me look at something real quick. There we go. Sometimes things kind of slip. There we go. So let's just walk through that code right there. So float rand y position is what we're essentially doing with that code is that random.range means we're randomly generating values between a minimum value for our y-axis and a maximum value for our y-axis. So that way it helps us randomize like whether our pipes are going to be starting higher or starting lower. And since we just initialized min y and max y the first time around, we need to initialize those variables at the top. Very important that you set these two values in particular as public. So just as a recap, whenever you set a variable as public in Unity, what happens is that you're able to access and edit those values in the inspector. So you don't have to constantly go back into the code and edit values. So that saves a lot of time in the future. So we're gonna declare for min y and max y. Now that we have that set, I think we can start with calling spawn column itself. So spawn column. So what we're going to do is we're going to reference our void method, which is spawn column, just to test it out. And what we're going to do is we're going to save. Well, let's first save and see if there's not any errors that pop up. Game object. Let me just name it to a capital G. Alright, so now that we have that set, what we're going to do is we're going to click column spawner. And we're going to add a component. We're going to add you're going to type column spawner or whatever you wrote for your script to spawn the columns. And you're on the right track if you see these three tabs right here. Min y and max y is what we set when we turned our variables public. And same for when we initialized our game object as public as well. So what it's asking us to put in is our column prefab. So it just so happens that we have our column prefab right here. And now what you're going to do is you're going to drag your prefab all the way into the column prefab section. And it takes in the prefab that you created. And let's see, what are some good values that we can use for min y and max y? Let's try negative 0.57. And then max y could be 2.67.
Wait, how are the like the units over there in the grid?
Wait, what are you referring to?
Yeah, because like you're saying like negative point something and 2 point something. Like how do you know like the range in that case? Like, I know like you're kind of playing with it, but like I guess like
Oh yeah, so I can demonstrate that by doing if I just bring on my prefab like right now. So if you want to test like any values, what you're gonna do is you're gonna move. Let's move it right here. And if you go into your inspector tab, pay attention to the values that you see here for position. So if I were to move down, like somewhere close to that, we're going to take the value that we have for our y, which is negative 0.55, and we're going to take in a value from somewhere in between two. So if you want to test this, just grab your prefab, put in the scene, and just move it around in the y-axis, and then pay attention to the y value in the inspector panel. That's a little bit too high. Yeah. So you can see like more or less how I got my values. So you're welcome to experiment with your own values and see what works. And then you can readjust, and you can always readjust those values in your column spawner script to see what works best. Well, let's try 2.57 in this case. Now, let's test out our spawner for the very first time and see if it works. Yeah, it worked. Kind of hard to see because we had a game object there spawn on top of it, but if I were to delete that, let's try it again. There we go. Now let's test it one more time. Oh man, yeah, spawned a little bit higher this time. You can see the sprite actually cutting off. Yeah, so we definitely got to play around with the values a bit, just to make sure that the pipes don't show that they're cutting off. But one thing we need to start fixing is adding a little bit more to our column spawner, because as of right now we only spawn in one pipe, and we wanted to spawn several pipes.
I mean, isn't there like a time function? I'm pretty sure there was one.
Yep, you're on the right track there. So essentially what we're gonna do is we're gonna use two variables in particular to measure time. So we're gonna use a float value for timer, and a public float value for max timer. So let's go back into the column spawner script. So as you said, we're gonna use variables for time. So float, timer. The reason why we have timer as just a float is so that way we don't have any means of changing that value in the inspector tab.
Yeah, it's supposed to always keep constant.
Yes, it needs to be kept within the script, so that way like no one messes with it in the inspector tab, because it might throw off the timing of like what your column spawn. And maybe you want it to spawn a certain way, and having that public just means that anyone could just mess that up. So what we are going to have public is the max timer. So essentially what max timer is that it's a value that we attach to our script that says, okay, how long until we spawn in the next column. So what we're going to do is we're going to write an update script. So if let's see, if that'll be timer plus equal to time delta time. So just to give like a quick little insight on time delta time. So delta time measures time in terms of seconds. which is very important because we don't want it to we don't want to measure our our timer flow in terms of frames, in terms of updating frames constantly. Because what happens is that it starts throwing off the timer value, and you won't get the intended results for measuring time. That's why we have the other reason why we have delta time in the first place is because it's in respect to, like, you know how we measure frames per second in games.
Yeah.
Time delta time helps with measuring time with seconds constant regardless of the frame rate.
Yeah, so like, I mean, I don't know, like if there's one like, like a function to get the time like in relative to the frames, right?
Hmm.
Like if you use that and suddenly like, like your game just like dropped from 60 to 40, like it will actually like cause everything to like change.
Yeah,
how it
your
works.
timer variable will be affected by the frame rate of the game itself, and we don't want that. We just want it to focus on the time itself, and we're just focusing on seconds as of right now. So timer plus equals time delta time. So we check that it measures in time, and we are going to make an if statement. So we're going to check if timer is greater than or equal to max timer. We write spawn column, and then we set timer back to 0 again. So just to update, so void start, what that means is that any code in void start automatically starts before the first frame of your game. So it checks before your game officially starts. And void update, what that does is that it update is called once per frame. So if you want to check something every single frame, this is where you put your code in. And this is exactly what we're doing. We want to check at every frame the timer and see if it reaches max timer, so that way it executes this code to spawn more columns and set the timer back to 0. So let's save that and see if there's not any issues. Nope. All right, so if we go to column spawner, notice we have a new tab right there for max timer. You don't want to see what happens if you set this spawner at 0 for max timer. Trust me.
It's just gonna expire.
You want to see it?
I mean, I'm pretty. Yeah, I can kind of feel like what's gonna happen. It's just like
Let-
blowing everything.
Let's hope that if I do that, it doesn't
Crash.
it doesn't crash Unity and the stream itself. Let's see. If it does, then I'll stop it like right away. Oh god.
Oh god.
Yep. Oh my lord. Look at that.
Oh man, you can't even see it over here. Like, yeah.
Yeah, because the stream is a little bit behind right now. Yeah, you would not believe the laughter that I had when I first saw that. I forgot to check off the max timer, and all those game objects started spawning in like crazy. You can imagine how much that kills your frame rate. So we're gonna set it to something more reasonable, like 1.5. And
There it is.
yeah, the stream's gonna love that when they see that. So let's do it with a more reasonable time of 1.5 and see what we get from here. It's probably gonna show up a little bit later, but let me see. Oh, there we go. So I'm just gonna let this play and let the stream catch up with like what's going on in terms of the randomly spawning columns. As you'll notice on the hierarchy, you'll see a bunch of different clones like starting to fill up the hierarchy. And we definitely want to avoid like having so much of that litter in your game.
Yeah, like when you want, like once they get like to the back, like just like delete them from the game.
Yep, you're on the right track with that one too. So yes, that's one issue that we need to solve right away is how do we destroy the game objects once they reach a certain point in the scene. So what we're gonna do is we're gonna return back to a previous script. So what we're gonna do is we're gonna do roughly the same thing. So wait, let's make sure that. Oh yeah, check to make sure that if you're gonna call something with a tag, make sure that your game object has the tag that you want. Because if not, your script is not gonna know what it's calling. Or you might know what it's calling, but Unity doesn't because you didn't specify. So let's see. All right, let's continue. Okay, so the same idea applies with the column tag. So we're gonna go if game object compare tag is column. Very important that we spell that correctly, because if not, Unity's gonna throw a fit. And what we're gonna do is we're gonna write an if statement. It's like you said, so we need to find a way to check once the column reaches a certain coordinate in the scene, it destroys the object right away. So we're gonna have a if statement that checks for that exact condition. So transform dot position x. So once the x coordinate of that game object reaches that magic number, then we execute the destroy command. So we set that x less than or equal to length limit. Now we don't have length limit initialized yet, so it's going to be float length limit. And then let me write this in the code. So if you're watching this in the replay, you're able to look at this. Checks when the columns reach the magic x coordinate. All right, so we do have a method that we in Unity called destroy. So simply rewrite destroy. I think that's it. I can always double check. All right, so forgot that a little bit. I thought for sure it was referencing the tag, but all right. Game object. Okay, so just to explain that, so essentially we're referencing the game object that passed that magic coordinate, which in this case is our pipes. So it destroys that instance of the pipe. So it doesn't like destroy like all the rest of the pipes in unison. So we definitely don't want that.
Yeah, because you put the tag like I guess like wait, oh put the tag or the game object. Okay.
No, I was
Okay, yeah.
no, I was misremembering whether it was the tag or the game object that I need to reference. Memory's a little spotty sometimes, having to remember specific details. Like the core concept is there, but sometimes when you're diving deep into code for too long, like sometimes you need a little refresher. All right, so there's no error in the code, so let's test it out right now. Oh wait, it's not. Wait, there might be something missing. Alright, let's look at the code again. Oh. Let's see. Let's see, what is going on? Alright, so maybe public float had to be initialized. Yeah, sorry about that. Things are sometimes I miss the small details. All right, let's see where else. Yo, what's up? All right, let's test out the column spawner this time around.
Like, how about you like also go like change to them? I tried to load it like several times and it doesn't work.
I think for me, I don't have enough space in the RAM, so I have to close.
Yeah, sometimes you gotta make enough space for Unity. Sometimes,
Yeah.
if it's not Android Studio like hogging all the RAM.
Oh my god. For real.
Yeah, Android looks at your RAM. It's like, can I please add more RAM?
I'm just gonna.
You're like eight isn't enough.
Go into your stream for a second. If it's
Like eight gigabytes of RAM is like not enough for Android Studio.
Oh my god, for sure.
Right, let me look at the column spawner.
That's all like this week. Not this weekend, this shall next. But next
So
week I'll
tomorrow.
just grind forever.
Yeah. Wait, you ever do like a keyboard challenge hacks? Or yeah, using like a manual? His team is crazy.
Yeah, his thing is
Is it
insane.
manual? Oh my
Manny,
god.
yeah.
Manual.
I know it's so crazy.
Did he ever show you his project they were trying to last year?
Yeah, he showed me like
Oh,
video.
that's so crazy.
Alright,
Oh, that's what
let's see what we got.
But did you, are you participating?
Yeah, but I mean, I just like met a guy recently, so like a freshman named Jacob. He was like in the like in a meeting they made.
Oh yeah, the team builder.
Yeah. But like we don't know anything, so I don't know what we're gonna do.
Alright, let me pause that for a moment. So,
That's one step closer to at least
See.
participating and then building something.
We have mentors, right? So
Yeah. The trade was.
I guess in the meantime, what I can do is I can make the score, and then I can probably come back to fixing the issue that's with the spawner. So, like one of the last things I can do is to show at least the score, or at least how to populate it. So, what we're gonna do is we're gonna create a empty game object, and well, not so much an empty game object. We're going to create a UI and then canvas. So when it comes to the canvas game object, that handles all sorts of, it handles the details as far as your camera. So one of the first things that we need to do is we need to drag our main camera into the canvas. So let's see. Wait. There we go, main camera. And we are going to set it on space camera. Drag main camera here. And essentially what's going on here is that our canvas is now focused directly onto what we see in the game screen right here. So we don't need to change anything in the settings as far as the playing distance. So let's see, there's no other settings in particular that need to be changed, because if we run it, canvas works as it should. Alright, so let's see what else we've got. So we need to now make a new object in terms of text. So we're going to go to UI, text, and whenever you make a text object, it's always going to be under your canvas. So you don't have to worry about moving it around to a specific location. So in terms of what we're seeing right here with the text in the inspector panel, we're going to label that as score text, and we are going to make some small adjustments. So we're going to set our horizontal as overflow, and we're also going to set our vertical overflow to overflow as well. And essentially what that does is that allows us to start our text from straight 0, and then we could adjust it to whatever size that we want. So as of right now, if I were to move this text object in the scene, there's nothing there. Now I'm going to write 0, and slowly but surely I'm going to expand the size of the text for a moment. Let's set that to middle. There we go. I missed the order and layer. Always the little things. So if we go back to score text, now I should be able to adjust the font size where it looks just about right. It's maybe a little bit more to the center. So if we want to add like shadows into our text, what we're going to do is we're going to add component, and we're going to go shadow, and then first let's set the text to white. I might have to zoom in a little bit so you can see the shadow itself. All right, so with the 0, we see a little bit of a drop shadow right there. I think just enough to showcase what's going on. So what do we got? What do we got left? So this is probably like a pretty important step because a lot of people get stuck on this section. So the first thing that we're going to do is we want it to where whenever Flappy passes through a pipe, a point gets added into the score. So the first thing that we need to do is we need to go back to our prefab. And we need to add what is called a box collider 2D. But we don't want Flappy to hit the box collider and just stop right there. We want it to be a trigger. So what we're going to do is we are going to add box collider 2D. We can see the square right there, but that's not the size that we want it. So if you look into your box collider 2D, you can offset the X and Y coordinates to where you want them to be in particular. So let's shrink it a little bit. Let's offset that. And now let's stretch that. No, that stretches the entire cube pipes. Let's go down. There we go. So we're going to be referencing this box collider 2D. So we don't want it to where Flappy just hits that invisible box collider and just like stops dead in its tracks. So if we wanted to just like have it be just like a simple checkpoint, what you're going to do is you're going to click on is trigger right here. And then once we are all done with editing our prefab, you can just simply back out. And if you want to check just to make sure that your prefab has all the settings saved, click on your prefab again, and you can see that the changes that we made to our template like carried over. All right, so let's see what we also need to do.
So wait, what does that box collider does?
Is so the box collider acts as like a hitbox for your object. So
It's like right in front of
yeah, we do that for a reason because since we set the box collider as a trigger, Flappy is just gonna go right through it. So if Flappy passes through that hitbox, something is gonna activate in the code.
the scoring.
Yeah, for scoring.
Oh,
So rather than Flappy just hitting that invisible hitbox and then the game is just over there, Flappy just continues going.
okay.
All right, so what do we got left? So we have the collider there. So I think now is when we go back to Flappy themselves. I guess before I do that, we can create a script called score. And then we go back to Flappy's main script for a moment. So I'm going to create a method called public void on enter trigger collision. On trigger enter 2D. Oh man, phone's all going off. That call is too spicy for the stream. So let's see, on trigger enter 2D. How much you want to bet that if I look at the rehearsal code, this is going to be off? Anyone want to take bets? Let's see.
Bet 10 once.
On trigger enter 2D. So let's look back. On trigger enter 2D. Okay, so that's definitely right there. So collider 2D collision. So essentially what this method does is that when an object passes through the trigger of our box collider, our code is supposed to activate something. So as soon as Flappy goes through that invisible collider that we set up, we want it to count 1 to the score. And I created a score script earlier that we're going to start messing with in just a bit. So let's make the brackets right here. So if collision print score up. So right now we're not doing anything to actually increase the score. What I'm writing here is just a print statement to check in the debug log. So this is one very important tool that you have at your disposal if you want to check if something works with your code, because oftentimes there's methods that you write that are kind of abstract, and sometimes you might not be able to see it, just like the pipes. Remember what happened when we set the pipes to zero spawn time? It almost crashed the server. I mean, that'd be a pretty wild way to end the stream. Just let my laptop implode in the process. All right, let me. All right, so if collision.compare tag equals column, so this references the tag that we made for our pipes. So that way our code knows, okay, if it passes through the pipes, then we print the score up. So let's take a moment to test out at least the debug log. All right, so we got no issues there. Might have to be the way that the column spawner is activating. Let me go into the prefab for the columns itself. All right, let's hold off on that in the meantime while I get the score script going on. So let's look at this carefully. So in terms of the score script, what we need to do is create an integer variable for score itself, so that way we have a way to keep track of it. And we're going to have this class as public for one very important reason, which is we need to bring the script back into our score text game object that we created a little bit earlier, because we're going to reference it later on in our birdie script. So what we're going to do is we're going to name it int score, and at the start of the program it's going to be score is set to 0 to match up with the text, and anything related to text that you use within Unity, you gotta import a library. So using Unity Engine dot UI.
I just have a question. I
Mm-hmm.
don't know if I'm late to ask this, but is there a way that we connected our VS Code, like C# code to Unity, or is that just, how did that work?
Oh, how does that work? So essentially, if you go into Unity, I believe it's in, if you go to Edit and go to Preferences, you can set the external script editor that Unity uses. By default, it's usually set to open by file extension. But if you want it to be specifically for the IDE that you want, so let's say Visual Studio Code, you can check that off, and the code in Unity will be tailored within Visual Studio Code.
Okay, that makes sense.
Yeah, so in case that you're not a fan of like using a particular script editor that doesn't work well with Unity, you can change it to whichever script editor that you want. So let's go back to score for a second. So we start with the fact that score equals 0, and what we want for void update is a way to update the script and the text in real time. So what I'm going to do is showcase this script right here. Is this script right here, and then walk through that carefully. So in terms of our void update, what we're doing is we're incrementing our score to 1. It checks every frame to see if we pass through the invisible collider that we set with our prefab. And then what we do is we initialize something called getComponent.text. So essentially getComponent is that it gets the information of the component for an object that we have. In this case, it's the text. And then we set that equal to score.toString. So that way it turns the information of the score that we have, which was currently an integer, into a readable string. And now we're not done with that, with the score script just yet. So essentially what we need to do is, this is probably like the most important step in this part of the workshop, because this causes a lot of frustrations if you don't set it up correctly. So once you have your score script set, you're going to go to score in your score text object. You're going to add a component, and you're going to write score, and you're going to write, you're going to look for the script that you made for score. And there, now your score text has the script needed to increment. But now we're not done just yet with the Birdie script, because now we're going to do something that's pretty important, which is referencing other scripts inside of other scripts. So let's say you want to use a method within score in Birdie. We need to find a way to reference that. So what we're going to do is, I'm going to write in the comments reference script. I'm going to write public score text. So essentially what we're doing is that we are making a public option within Birdie to check for the score text. So if I were to save that right now, let's go to, that's going to get thrown an error because there's something that I'm missing within the code. Yeah, as you see, since that error is happening because since I didn't finish with declaring a score all the way. But the idea is that once you finalize with referencing a score, you will receive a new option under the Birdie script, which is score text, which is which is the script asking, hey, we need the object for score text to link it to Birdie, so that way every time it passes through the pipes, it adds one point to the score. So let's go back to our script for a moment. So let's take a moment to look at the Birdie that we have here. So we reference the name of our public score text, and we're calling the method that we made back in the score script, score up. Void score up. There we go. So yeah, now that looks solid. So now when you go back to the Birdie script, if collision.compare tag column, so that means if Flappy passes through a tag that's mentioned as column, it'll print out score up as our debug log to check that if it works, and then it goes into the script for score and writes score up. So let me just save that. Now let me take a moment to save. Let me take a moment to see if I can open up something in terms of a script. Let's ignore the update check, because usually with Unity updates, they always seem to break something that you're always so commonly used to. So let's test something out right here. So this is how the script will end up looking like once everything is all set up into place. So as you can see, when we set our invisible box collider with the trigger, the moment you see Flappy passing through the invisible hitbox, you can see that score accounting like 1 each every time. And also you can see within the scene that once the pipes reach a certain coordinate, they were moved out of the scene, so that way we don't run into the issue of where we have like infinite amount of columns like spawning and slowing down your system to a crawl. But other than that, that's at least the last of like the major things that I wanted to cover, at least with the Flappy Birds projects. So one of the things that I wanted everybody else to experiment with, like as I upload the rest of the footage, is to try to see if you can make your own iteration of the Flappy Birds project based on the starting point that I left you guys on. Because it's one thing to just constantly go through the project and just complete it like just by watching it. It's another thing to take what you saw from the workshops and add your own flair to it.
Definitely.
All right, but does anybody else have any last minute questions before we wrap up the live stream?
I just have a quick question.
Mhm.
So, you know how we make that target where the score is going up?
Mm-hmm.
Like, how do we just, for instance, if it touches a pipe, right?
Mm-hmm.
And we just want it to just dive in, basically, right?
Mm-hmm.
Essentially with the Flappy Birds.
Yeah.
So, in this case, are we gonna make another target for it?
For Flappy to go past as a trigger?
More so like on the pipes. So if it hits the pipe, it will be like, okay, immediately score 0.
Okay, so that's pretty easy to implement. So what you need to do is you would set up a box collider for the pipes themselves. So just to give an example, if I go to the prefabs folder and go to column, what you would need to do is you would need to set a box collider. And you would see that you have this green outline on your pipes. And that also travels upwards right here. So if I were to play it right now, yep, Flappy gets hit by the pipes. Any other questions?
I missed majority. Can you start from the beginning?
Yeah, sure. Let's go all the way to the beginning.
From the top.
All right, let's nuke this project right away. X. Bingo. Do you want me to nuke the files live on stream?
Huh?
You want me?
Just do everything from the beginning.
All right, so
Let's start with the timer 0. With the timer 0.
How do you design the sprites in the enemy?
all right, so in order to answer that question, we need to go all the way back to the beginning. So let's time travel back to Tuesday. All right, so I'm about to wrap up this stream if nobody else has any other questions. All right,
Yeah. How would you export this game? Like to have like an icon on your desktop or something?
yeah, so unfortunately I don't have enough time to go into that.
Okay.
That'll probably take about another 30 minutes and someone might come in.
Okay. That's the same question.
Or you mean the next workshop?
Yeah, next.